Hello guys. So hopefully after last week's class you are experts at factoring, and we're going to really spend one more day on factoring where we're actually using it for a purpose. So the correlation between all the factoring that you're doing and something that we can actually apply is that the factors help us graph polynomial functions. And so we're just going to stick with quadratic functions, right? So remember, we talked about this a long time ago, but the parabolas, we're going to look at graphing those. But really, as you get into higher mathematics, you'll learn how to factor like cubic functions, which look like that. You can do what we call quartic functions, so cubics x to the third, quartics x to the fourth. And that looks more like a W, and so the higher the power, the more twists and turns you get. Okay, so what we're going to look at here is just quadratics. We're just going to focus on those parabolas, and we're going to see how the factors actually help us graph these. And once you know how to graph, you can really relate it to tons of different things. If we have some time at the end, we're going to do a little bit of modeling. So think about all the things in the world that make a sort of a quadratic shape. Any projectiles, right? So rockets, bullets, balls you throw in the air, the football that you're tossing around, anything that goes up and comes back down makes a quadratic shape. We can model it with a quadratic function, figure out when it's going to land, how long it takes to land, how far it can go, all those types of things. And like I said, we'll get to that a little later. But first, let's think about our quadratic function, ax squared plus bx plus c. One thing we have to know from this is that the a value dictates whether the graph faces up or faces down. And we talked about this a while ago with transformations. Remember, if a is positive, the graph faces up. If a is negative, it's going to reflect over the x-axis. So if we had negative x squared, it's going to face upside down. So if a is positive, that's what the greater than 1 says. We're going to have a smiling parabola. If it's just x squared, it will cross at 0, 0 and nowhere else. If a is negative, we're going to have a frowning parabola. It's sad because it's so negative. And both arrows would go down. Okay, so that's what that means there. So that's the first thing we need to know when we're graphing. And then every quadratic function has what we call zeros, or two values that you can put into the equation that will make the whole thing equal 0. That's what we're going to find by factoring, okay? So there's a couple situations. Your quadratic function could look like this facing up and have two zeros, and the zeros are just where it crosses the x-axis. Or alternatively, it could face down and have two zeros. It could have one real zero, so where it hits in just one spot and bounces back up, or where it hits in just one spot and bounces back down. That means it's going to have the same number twice. So these are your perfect square trinomial type equations. Or it can have zero real zeros, and these are actually imaginary numbers, which we're not going to get to this year, but if you take some higher math classes, you'll take a look, and that's where it just doesn't cross the x-axis, okay? So those are what our three types of graphs can look like. A zero is considered an x-intercept. We can also call it a root. So you might hear, how many real roots do you have? Well, you can have 2 if it crosses twice, you can have 1 if it crosses once, and you can have 0 if it crosses not at all. Or if we're dealing with equations, these are considered our solutions, okay? So these words are somewhat interchangeable: zeros, x-intercepts, roots, solutions. They're all talking about those same values there where the graph hits the x-axis. So let's use your factoring knowledge to help you figure this out. So in example 1, 3v squared plus 18v, it's going to be an equation now, so you should have an equal sign. And the first rule about this is we always want it equal to 0. Okay, so if our equation isn't equal to 0, we have to make that happen. So then we're going to think about factoring this. So if you have two terms, 3v squared and 18v, I'm going to factor using the greatest common factor. It's always what we want to try first. So next step is to factor. Well, 3v squared and 18v, I can take out 3v from each. So my factors are 3v, and then if I divide, I get v plus 6. If you can hear that crashing in the background, that's just my cat, sorry. V plus 6 is the second factor. So now we have two separate factors, and the third piece of this is to find our zeros using what we call the zero product property, or ZPP, okay? So we're going to take each 0, so that's my first one, that's my second one, and we're going to set them equal to 0, and we're going to solve for the value of v that would make them 0. So I'm separating each one of these out. The reason I can do this is because if 3v equals 0, then 0 times anything is going to be 0, right? Or, oops, that's not what I wanted. If I know that v plus 6 equals 0, then 3v times 0 is going to have to be 0 still. So if I can make one of those factors 0, then the whole equation is equal to 0. All right. So down here, I'm just going to solve 3v equals 0. Well, divide by 3. So v equals 0. That's one of the zeros. V plus 6, I would take away 6. So v equals negative 6. So once you get good at this, you can sort of do this in your head, right? 3 times 0 is going to give me 0. Or negative 6 plus 6 is going to give me 0. So did I necessarily need the full equation? Maybe not, but we can always get the answer that way. So that's what the purpose of that factoring is for. And then if I wanted to go and graph this equation, well, I know that this, in my original problem, a is positive, right? So the ends of my parabola are both going to face up. And then this graph hits at 0 on the x-axis, and it also hits at negative 6, which I'm just going to estimate. And if both the arrows go up, it's got to dip down and come back up right through that, all right? So a sketch of the parabola is just a very general, we're not going to worry about specific points. You just want your two zeros and then know if your graph should face up or if it should face down, okay? All right, let's try another. So 5n squared equals 20n. So again, we have our first step is to set it equal to 0 if it's not already. Well, this one says 5n squared equals 20n. So if I want to equal to 0, I have to subtract 20n from both sides. Okay, now same as before, it has two terms, so look for greatest common factor. 5n squared and 20n, I can take out 5n. Oops. And then once I divide that, I would have n minus 4. So second step is to factor, we just did. Third step is to find the zeros using our zero product property. So again, let's break this down. I'm going to say 5n is equal to 0, and I'm also going to say n minus 4 is equal to 0. Right. So if I want to solve 5n equals 0, divide by 5, so n equals 0. That's one of my zeros, or one of my solutions to this equation. On the right-hand side, if I add 4 to both sides, n is equal to 4, that's the second zero. Again, you might be able to do this in your head. 5 times 0 should equal 0, and 4 minus 4 should equal 0. So those are the two values that I want, right? So graphing that, we are going to have points at 0, a point at 4, And again, 5 is positive, so I know this graph is going to go up. Okay, simple as that. All right, so this next one here, I'll go through it a little bit more quickly, but I just want to show you what's going to happen if there's a negative a value in the beginning, right? This piece here is negative. So again, we're going to set it equal to 0. So I'm taking away 3a. So, 3a squared minus 3a is equal to 0. And one little trick, you always want to move the smaller power to the side with the higher power. Okay, so you want it to go from highest power down to lowest power to get you the right value there. So we're always going to try and move things towards where the higher power would be. Then look for greatest common factor. To me, it looks like negative 3a. Dividing by that, I get a plus 1. Remember, if you take away the whole piece, the whole term, you need to put a 1 in as a placeholder. Using the zero product property, set each equal to 0. And if I divide, I get a equals 0. If I take away 1, I get a equals negative 1, right? So those are my two zeros, 0 and negative 1. They're very close together this time. And because a was negative, this graph is going to face upside down instead of right side up, okay? So that's the only difference there. If this value starts negative, we want our graph to go down in both places. All right, let's think about one that's a different type of factoring. So x squared plus 6x equals 16. Steps are still the same. Get it equal to 0, and then factor. Again, I'm going to move the 16 to the side where the power is highest, and we can't combine 16 with x squared or 16x, so it has to stay solo. Well, this is a trinomial where a is equal to 1, so we're going to use product sum. So find me the two numbers that multiply to negative 16 and add to positive 6. So 1 and 16, 2 and 8, I think we got them right there. If we make 2 negative and 8 positive, those would add to positive 6. So my factors become x minus 2, x plus 8, okay? And then zero product property says, what is the value of x that is going to make each of these factors equal 0, right? So think, what number minus 2 equals 0? Well, it should be positive 2, right? 2 minus 2. If we weren't sure, we could make ourselves a little equation. And hey, we figure out x equals 2. All right. For the second one, what plus 8 gives me 0? Well, the opposite of 8 would be negative 8. So x plus 8 equals 0. Again, this is just a check. X equals negative 8. Those are the two zeros that I'm looking for to see where my graph crosses. So 1 all the way back at negative 8, 1 at 2. The a value was positive, so both arrows going up. Don't worry about how far that minimum value comes down. Just sort of estimate it and get it to go through both of your zeros. Okay? Okay, I think maybe 1 or 2 more examples here. If you feel like you got it, go ahead and start trying the assignment. But I'll just do 2 other types of factoring just so we remember. So if you look at this one, x squared minus 64, they're 2 perfect squares here, right? And a difference. So this is your difference of squares. It's already set equal to 0. So we want to think about taking the square root of each value. Well, the square root of x squared is x. The square root of 64 is 8. So my factors are x plus 8 and x minus 8, right? So I'm going to do this without making my equation, my separate equations, just thinking about it out loud. What number plus 8 gives me 0? Well, the opposite of 8 is negative 8. So x has to equal negative 8. What number minus 8 is equal to 0? Well, 8 minus 8 is equal to 0. So x is equal to positive 8. Sorry, all those noises are my husband coming home to eat breakfast from work. This is a very interrupted video, and I apologize. But anyway, those are my two zeros. So on the graph, negative 8, positive 8, and when the graph faces up, so it would look just like that. If we had instead a perfect square trinomial, so x squared, let's see, minus 16x plus 64, where this was x minus 8 and x minus 8, well, then your graph would only have one solution, 1, 0, which is positive 8. It's the same for both of them. 8 minus 8 is 0. 8 minus 8 is 0. So it hit at positive 8. It's just going to bounce and turn back around. Okay. And lastly, one with a slide and divide. We have to do that because there's a number in front of x squared. So first I'm going to set it equal to 0, so take away 7 from both sides. So 7x squared plus 48x minus 7 is equal to 0. Take that a value and slide it to the c value. So x squared plus 48x minus 49 is equal to 0. Now think about your product sum. What two numbers multiply to negative 49 and add to positive 48? That's got to be 48. Oh, sorry, not 48, 49 and negative 1. All right, so x plus 49, x minus 1, and then we're going to divide by a, which was 7. So 49 sevenths is really 7. 1/7, that doesn't divide, so I'm going to bring the denominator to the front of the x to the coefficient, and we get 7x minus 1. All right. So for these, it might be easier to find your zeros from this piece here. But if we take each factor, so one is x plus 7 equals 0. The other one is 7x minus 1 is equal to 0, to try and find what those roots or those zeros would be. The first one's easy. It's just going to be negative 7, the opposite of the number we have here. But this one actually has two steps, right? So 7x is equal to positive 1, divide by 7, x is equal to 1/7. So when you're graphing this, that's very crooked, we have a 0 at negative 7 and a 0 at 1/7, which is like really, really close, right? And then both arrows go up because it was positive, okay? So give yourself some practice.